Alright, today we are going to be continuing with learning about and practicing the method of elimination. We're continuing with our same standards, 8EE6 and EE8B, about solving systems of equations through graphing, elimination, and you're going to learn one other method this week called substitution. By the end of this lesson, you'll be able to determine the solution to a system of equations through elimination. Same objective as yesterday. We're just practicing this a little bit more today. You'll know you're successful when you can use knowledge about least common multiples and manipulate your system of equations to allow for one of your variables to be eliminated, thus allowing you to find a solution to the system. Okay? This is our lesson preview. We're going to review some things, do examples and exercises. We'll close out the lesson and do an exit ticket together. Please make sure your video is on and your mic is muted. You're showing your thinking and work. You're participating in your group work and breakout rooms. If we do those, you're having appropriate conversations. You're letting me know if you're having any technology issues. You're remaining respectful, responsible, and safe, and you are completing your class jobs. Please keep in mind that this lesson is very important for you specifically this week because there will be a question or two on your test on Friday about elimination. So this is really important to your life right now in the short term, but in the long term, you would need this information for high school and for college, and should you go beyond that, maybe even in your workforce. Okay, let's get started with this. All right, just to build a little bit of background before we get into our math today, I just want to go over some things. So if we look off to the left at this equation or this set of equations, we have two equations stacked on top of each other with a bracket off to the side, and we call this a system of equations. Okay? To solve this system of equations, the solution is going to be wherever these lines cross, because these are linear equations, and you can tell because they have y's and x's, and there's no exponents, so that means these create a line on a graph. Okay, so if we were to graph these, that is one way to solve them. If you graph these and you find, hey, this line crosses this line right here, that point is going to be your solution. All right, so before fall break, we spent a lot of time graphing these systems of equations to find a solution. And when we did that, we always put it in the slope-intercept form, y equals mx plus b. Just a little bit of background knowledge about that. Our m is our slope, and our b is our y-intercept. Okay, and we've been practicing that for about a good month or so now. Yesterday, we were introduced to this process called elimination, which is a second method to solving a system of equations, because we're not always going to have a graph, and our graph is not always going to show that the solution lines up on crosshairs, right? So sometimes the solution is in the middle of a line, and we can't just guess it. We can't say, oh, this is at 3.3, right? We have to actually solve it mathematically. So that is where elimination comes in. And elimination is just how we will be solving for today. Tomorrow we'll learn a different method. And what I'm doing right now is I'm just going to show you an example of elimination. So if we have our system stacked on top of each other, we are trying to eliminate one of our variables, and we do that by adding them together. So if I were to add these two equations together, add my x's, well, they cancel, right? Negative 1x plus 1x, that gets eliminated. So that's our process for today. 3y and 2y would be 5y's equals 10. And then we would divide by 5, find that y equals 2. From there, elimination, we have to plug this y equals 2 back into one of these equations and solve for x. And then we would get our answer as an xy coordinate. So that is what we're going to continue to do today. If you look off to the left at this little system I put it for you over here, this is actually what you're going to be doing for your exit ticket today. So you'll see that it doesn't always line up like this, where our variables cancel immediately. Sometimes we have to manipulate our equation a little bit, and we will do that today we'll get a lot of practice in. So let's go ahead and move into example number 1. All right, for example number 1, we have two linear equations stacked on top of each other. We have a system, and I want to use elimination to eliminate one of these variables. The first thing I always want to do is I want to rewrite my equations so that there's no minus signs and so that everything is stacked nice and neat on top of each other. So I'm just going to do that right here. This y is actually 1y, so I'm going to put 1y. All right. And now I have my equations stacked directly on top of each other. And I'm ready to get started trying to eliminate this. So what I'm going to do is I'm going to look at my x variables and I'm going to look at my y variables. And I'm going to ask myself, which one of these is going to be easier to just eliminate? So remember, we will be adding these equations. So I just want to look at it. If I add my x's together, 8x plus negative 8x, they get eliminated. So that is the choice I'm going to make here. I'm going to eliminate the x's. You could definitely eliminate your y's, but you'd have to do a little bit more math because 5 and 1, they don't eliminate. That makes 6. So we'd have to turn that 1 into a negative 5. But I've decided I'm going to go with my x's, so I'm just going to say I'm going to eliminate my x's. That's the first thing I'm going to do. All right? And I don't really have to change anything about this format, so I'm just going to go ahead and add. So I add my x's together first, and they cancel out. They eliminate. There are 0 x's left. 8 plus negative 8 is 0. Keep my plus sign. 5y plus 1y is 6y's. And 19 plus a negative 1, or 19 minus 1, is 18. Okay? So now I have 0x plus 6y equals 18. That's the same as saying 6y equals 18 because 0x's means there's nothing there. From there, the second thing I'm going to do is I'm going to solve for one variable. In this case, the one variable is the y. So I want to get this y by itself. Right now, it is being multiplied by a 6, so I'm going to have to divide by that 6. And if I do it to one side of my equation, I do it to the other. And I'm left with y equals 3. So I got y equals 3. What am I going to do with this answer? Because that's not my full answer. I need an answer as like an ordered pair. I need an x value as well. Well, now I'm going to take that answer and I'm going to plug it into one of my equations up here. It doesn't matter which one you choose, but that is my next step. So plug in your answer. To find your second variable. And I'll explain that as I do it right now. So I'm looking at my two equations up top. I think I'm going to go with the second one. And the reason is it just has smaller numbers. The top one has a 19 and a 5. The bottom one has a negative 1 and a positive 1. Those are just easier numbers for me. So I'm going to go ahead and rewrite this equation off to the side. And wherever there was a y before, I'm going to be putting this 3. So I have negative 8x plus 1y, and now it says 1, 3, because that was what I got for y, right? Equals negative 1. From there, I'm just going to solve algebraically, going one step at a time. Well, first thing I want to do is any multiplication of parentheses, so that is what I'm going to do. 1 times 3, that's my first step here, and that equals 3. Everything else in my equation stayed the same. All right? From there, I'm trying to get my x completely by itself. Right now, there's a couple things going on beside it. It is being added to 3, and it's being multiplied by negative 8. The first thing I'm going to undo is my addition. That's what I always want to undo. The opposite of plus 3 is minus 3, and I do it to both sides. Over here, it cancels. Over here, negative 1 and a negative 3, that makes negative 4. Everything else on the side stays the same, negative 8 times x. From there, I'm still trying to get my x completely by itself. Right now it's being multiplied by a negative 8, so I will divide by negative 8. And I will do that on both sides. On the left, it cancels, and I'm just left with x equals, on the right side, negative 4 over negative 8. Well, negative divided by negative is a positive, so this would actually be 4 over 8. And that reduces to 1/2. You could also write it as 0.5. But that is my answer for x. Okay? So now that I have found my second variable, I'm going to write my answer as a solution. And I do that as writing an x, y pair, because my solution is wherever these lines cross. So the solution to this system of equations is going to be 1/2 for my x and 3 for my y. All right, and that is what we're going to practice today. You're actually going to get into this practice on the next slide on your own. We're going to alternate examples and exercises today. Please make sure you have this down, and we will move forward. All right, I want you to go ahead and begin this on your own. The first thing I want you to do is line up your variables. So go ahead and just rewrite these equations, making sure there's no minus signs. Your x's are on top of your x's, your y's are on top of your y's, your equal signs are on top of your equal signs, etc. And I'm going to give you about 20 seconds to do this. All right, check your work with my work. Did you line it up correctly? Is your 3x on top of your 6x? Did you change that minus sign to a plus negative 5y? And that should be on top of your positive 5y. And 17 and 10 should be lined up. So everything should be lined up. Second thing I want you to do is look at your variables. Decide which one you're going to eliminate. Okay? Do you want to eliminate your x's or your y's? Message me in the chat and let me know. All right, well, looking at this, you should have identified really quickly that if you were to add these equations up, your 5's are exactly opposite, and your y's would cancel immediately. So you're going to eliminate your y's. All right? Next thing you're going to do is go ahead and add these equations up. So please add your x's together. Tell me what they equal. Add your y's together. Tell me what they equal, and add your numbers together so that we create one equation. Give you about 30 seconds to do that. All right, you should have got 6 x's, 0 y's equals 27. Okay? From there, we know that this doesn't mean anything, so this is the same as saying 6x equals 27. The next thing I want you to do is solve for x. Solve for that variable. Get x by itself. What does it equal? Take a second to do this because it's literally just one step. All right, check your work with my work. I divided both sides by my coefficient of 6, and I got x equals 27 over 6, same as 27 divided by 6, and that turns into 4.5 as a decimal. I don't care which way you put it. You could write it as that fraction or that decimal. Okay? You're now going to take this answer, and we're going to plug it in to find our y. So we want to plug it into one of these equations. It does not matter which one you choose. I always want to choose the one that has the smaller numbers. These ones are pretty similar though right now. So I'm thinking I'm going to choose the second one just because there's no negative signs there. So that's what I think I'm going to decide to do. So our next step is to plug in and solve for your second variable. In this case, it's our x. So I'm going to rewrite this equation off to the side, and you need to do it the same. 6x plus 5y equals 10. And we know that x is 4.5, so that's what I'm going to change this x to. So it becomes 6 times 4.5 plus 5y equals 10. Go ahead and get y by itself and tell me, what does y equal? Solve for y. Take about 30 seconds to do this. You have calculators, so you should not need more time than that. All right, go ahead and check your work with my work. We went through this pretty slowly. I show you everything I do in blue right here. So the first thing I did was 6 times 4.5. I got 27. Second thing I did was I took 27 away from both sides. Third thing I did was divide both sides by 5. And I got my final answer of y equals negative 17/5, or negative 3.4 if you want to write it as a decimal. Okay? So the last step is to write your solution. As an ordered pair. And so we want our x to go first. In this case, it's 4.5. And our y to go second. In this case, it's negative 3.4. So this is my solution. Make sure you have it down. And we will continue on to a new example next. All right, moving on to this new example. The first thing I want to do is make sure everything is lined up. And in this case, it is not. I do have my x's on top of my x's, so I can keep my 1/2 x here and my 2x here. Got a plus sign. But the next thing, I have a plus 5, and on the bottom I have a plus y. I need my y's to be lined up. So what I'm going to do is I am going to move my 5 to this side and my y to this side. That means this y has to be taken away to move over here, so this becomes negative 1y. And my 5 going to the other side has to be taken away from that side, so it becomes minus 5. On the bottom, everything stayed the same. I have 1y equals 1. All right. From there, I am going to decide which variable I want to eliminate. Now, it is very simple here because all I have to do is add these up and the y's will eliminate how they are. But I'm going to show you guys that it will work even if I decide not to eliminate those y's. So I'm going to decide to eliminate my x's. Okay? But that means my x's have to be the same number and one has to be an opposite. So I'm going to choose the least common multiple to be 2. So I want to turn this into a negative 2. How am I going to do that? How do I get 1/2 to become negative 2? What do I multiply it by? Well, if I want it to be a negative 2, I would have to times it by 4, and I would have to times it by negative 4. So this entire top equation is going to be multiplied by negative 4, so that this becomes negative 2x. So that's what I'm going to do down here. I'm going to multiply my entire top equation by negative 4, so that my x's become a negative 2. All right? Negative 4 times 1/2 is negative 2x. That's exactly what I wanted. Negative 4 times negative 1 is positive 4. Keep our y's. And negative 4 times negative 5 is positive 20. So I just took this top equation and rewrote it. I rewrote it so that my x's would be a negative 2x's. And I did that just by multiplying by 4. My second equation, right here, nothing changed. It stayed the exact same. So I'm just going to rewrite it down below so that they are stacked on top of each other. And from there I have my system, so I'm going to go ahead and add and solve this. These cancel. I'm left with no x's. These y's add to 5y's equal 20 plus 1, 21. Next step is to solve for that y, so I will divide both sides by 5. And I get y equals 21 over 5. If I want to turn that into a decimal, I can really quickly. 21 divided by 5 comes out to 4.2. So I've got my x. The next thing I'm going to do is I got my y. The next thing I'm going to do is use that to find my x. So I need to plug this in to one of these equations. Doesn't matter which one. I'm going to choose my second one, the one I highlighted in red, because there's no decimal. So I have 2x plus 1 y equals 1. And I am changing this y to what I actually got for y down here, 4.2. So this becomes 2x plus 1 times 4.2 equals 1. And I'm going to quickly solve this out. First thing I'm going to do is 4.2 times 1. This is 4.2. Everything stayed the same. Next thing I'm going to do is take away this 4.2 from both sides. Over here it cancels. I'm just left with 2x's equals 1 take away 4.2. It's going to be negative 3.2. Next step is to divide both sides by this coefficient of 2. And I get x equals negative 3.2 divided by 2. And I'm going to do that in my calculator real quick. And I get negative 1.6. So I have my x, I have my y, and I'm going to write it as an ordered pair. Negative 1.6, 4.2. That's my solution. All right, moving on. All right, you're going to practice here. The first thing I want you to do is make sure everything is stacked up. And it looks like it is right now, so you don't have to rewrite this because everything is stacked up and you have plus signs. So what I want you to do right now is decide, do you think you should eliminate your x's or your y's? So look at your x's. They would have to be the same number. And look at your y's. These would also have to be the same number. Remember, there's an invisible 1 right here. It's completely up to you what you decide. Okay? No answer is wrong. I'll show you both ways. Okay? So if you decided to eliminate your x's, I'll do a problem set right there. If you decided to do your y's, I'll do a problem set right there. So for your x's, if you decided to eliminate them, you know that you need to get both of these numbers to be the same. One's already negative. One's a positive. So that's awesome. But they both have to be the same number. So I'm going to turn that 3 into a 9. So how do I do that? I want to turn this into a 9. Well, I multiply by 3. And I'm going to times this entire equation by 3. So if you chose to eliminate your x's, you need to multiply that entire bottom equation by 3 and come up with an answer. Or a new solution, a new equation, I'm sorry. If you chose to eliminate your y's, then you're going to be turning this bottom y, you need to match the top number but be the opposite, you're going to turn that into a negative 2. So how would I turn that into negative 2? Well, I would just multiply by negative 2. So if you're doing the y's that you eliminated, you're going to multiply that top equation by negative 2. Or sorry, it's actually the bottom equation. So I have negative 2 times negative 3x plus 1y equals 2. All right, so take a second right now. Whether you choose to do your x's or your y's, don't choose to do both because you don't need to do that. That's way too much work. And go ahead and rewrite your new equation after you've distributed. I'll check your work with mine in just a second. All right, check your work with my work and make sure that you have distributed correctly. So for this one right here, if you decided to eliminate your x's, you're going to be stacking this new equation because you changed this red equation, right? You're going to be stacking it with that one that was on top. So this is 9x plus 2y equals 9. And I want you to add these up and eliminate a variable. If you chose to eliminate your y variable, then you're going to be stacking this number up with your top one as well. We have 9x plus 2y equals 9. So go ahead and add that up. Whichever one you choose, eliminate one variable right now. And check your work with me in a second. Alright, so for this, here's what I did. For the first one, I eliminated my x's and I just stacked these up. 3y's and 2y's, 5y's equals 6 plus 9, 15. For the second one, 6x's and 9x's, 15x. These were eliminated. And negative 4 and a 9 equals 5. So from there, we are going to solve. So I want you to solve for your variable, whether you're solving for y or you're solving for x. Do your division and tell me what it equals. Alright, if you did this one over here on the left and you were solving for this y, 15 divided by 5 is 3. If you were doing this over on the right side and you did 5 over 15, this is the same as 1/3 or 0.33 repeating. Okay? So one group was able to find our y for us, the other was able to find our x for us. So we actually do have our system solution right now. Our x value is going to be 1/3, and our y value comes out to be a 3. So this is our solution. We kind of work together to do this work today. For this one, we kind of split up the work. We're going to move on to example number 3. All right, for example number 3, the first thing I want to do is make sure everything is lined up. And it looks like everything is lined up. I have my y's, my x's, and my numbers. I'm going to change this a little bit. I want this to say 1y because this should be a 1. I'm just going to rewrite it really quickly. And I'm going to change these minus signs to plus and negatives because it's just easier. All right, from there I need to decide, am I going to eliminate my y's or my x's? It's really the same amount of work no matter which one I choose. I think I'm going to eliminate my x's. So if I'm looking at my x's right now, they have to be the same number and they have to be opposite. So I know that 2 goes into 4. It's a multiple. 4 is a multiple of 2, so I'm just going to change this 2 to a 4. So I'm going to change to 4, and I'm going to change to a negative 4 actually, so it'll cancel with that bottom 4. And to do that, I just have to multiply it by negative 2, right? So that means I'm going to be multiplying that entire top equation by negative 2 to create a new equation. So I'm going to do that really quickly. Negative 2 being multiplied by all this. Negative 2 times 1y is negative 2y. Keep my equal sign. Negative 2 times negative 2, negative 4x. That's what I wanted. And negative 2 times negative 2 is 4. So I just changed this top equation to this. I'm just going to rewrite both of my equations so that they are stacked together. So I have negative 2y equals negative 4x plus 4, and I'm just going to rewrite this one right below. So this one is 2y equals 4x plus negative 4. And I'm going to add these together. My y's eliminate. There's nothing left there. My x's also eliminate, and my numbers eliminate. What does this mean? If everything was eliminated, there's nothing left. What do you think the solution to this equation or the system of equations is? I want you to take a second and give me a guess in the chat. What do you think that means? Remember, there's 3 types of solutions. One solution, no solution, or infinite solutions. So if I have nothing left, what do you think that means? Well, you would think that having nothing left, that would mean that there's no solution. But actually, if I were to solve this out, this is the same as saying 0y's equals 0x's plus 0. Is that true? Yeah, 0 does equal 0. So this is an infinite solutions answer. Okay, special kind of work. All right, for this one right here, I've gone ahead and I've rewritten it out for you. I put the coefficient of 1 in front of your y's, and I changed our minus sign to a plus sign. I want you to decide which variable do you think we should eliminate. Which one looks easier to eliminate? Well, in my personal opinion, the easiest one to eliminate is our y's because they're already the same number. So I just need to make one of those a negative, okay? It does not matter which one you make a negative. I'm just going to make my bottom ones a negative. So if I were to multiply this entire thing by -1, all of my signs would change. So I don't really have to do much math here. All I have to know is that if I multiply everything by -1, everything becomes a negative. And now I want you to add it up and tell me what you get when you eliminate those y's. Okay? All right. So for your x's, if you have 4/3 and you take away 1 whole, which would be 3/3, so 4/3 minus 3/3, left with 1/3 for your x. Over here, we're left with nothing. And over here, a -9 and a -3 is a -12. So this is our equation right now. We eliminated our y's. We have 1/3 x and a -12 equals 0. So I'm going to rewrite that right here. Now we need to get the x by itself. Right now it has a plus -12. So we are going to do the opposite of plus -12 and add +12 to both sides. Just solving algebraically. Over here it cancels. Over here it adds to 12. And we're left with 12 equals 1/3 times x. Okay, we're still trying to get x by itself. Right now it's being multiplied by 1/3, so the opposite would be to divide by 1/3. Over here it cancels and you're left with x equals, and on the left side, 12 divided by 1/3. Well, if you do keep, change, flip, 12 divided by 1/3 is the same as keep, change, flip. So 12 times 3, 36 is what you get for x. Okay? Now I want you to take this 36 that we just got, and I want you to plug it into one of your equations to solve for y. So whether you choose this one or this one, plug in your x and solve for y. I want you to tell me, what does y equal? And I'll show you my work in just a second. All right, well, I chose to plug my 36x into my original equation right here. And so it said y equals x plus 3, so I changed it to y equals 36 plus 3. And 36 plus 3 is 39. So my y is a 39, and my x is a 36, and I'm just going to write that as an ordered pair. X comes first, 36, 39. That is the solution to these equations. Okay, moving on. So we have done our practice for today. This is our new learning. I want you to always line up your variables first. And again, it's not new learning, we're practicing what we did yesterday. Decide which variable you want to eliminate. Apply properties of equality to manipulate or change that equation. Solve for one of your variables, and then use your answer to solve for the second variable. If you're not confident, go back through, rewatch some of these examples before moving on to the exit ticket. All right, here's your exit ticket for today. The first thing I'm going to do is help you out just a little bit by making sure these variables are lined up. So I'm going to be switching my y and my 3 so that these are lined up correctly. So I have 1x plus, I moved my y over so it becomes negative, so -1y equals, and I move my 3 over so it becomes -3. So I just changed this top equation to this. The bottom one stayed the same. So it's up to you to decide which one of these variables you want to eliminate. From there, you will manipulate your equation accordingly. Maybe you want to change the x's to be eliminated. you would change them both to 3's. So you change that top one to a -3. Or you want to change your y's to be eliminated, you could change that top one to a 4y, -4y, and it would cancel. It's completely up to you. But I want you to go through the steps, go through the process. You can look back at the slide before and it'll show you the exact steps that we take each time. Solve for one of your variables, use that variable, plug it into an equation, and solve for your second. And I want you to give me your solution as an x, y ordered pair. Okay, do your best. Take your time. It's a lot of math, so go slow. Use your calculator, and good luck.